I hope all is well for you. Today we will see who decided that everything multiplied by 0 equals 0. This video is brought to you by the Question Response channel. I thank Robert M. Dukes, Dave Consiglio, Nandan Choksi and Alan Bustany for their answers to this question. We will start with the first of Robert M. Dukes.
The best way I've found to think about multiplication is area. Say you have a patch of land that is 6 feet on one side and 5 feet on the other. You want to cover it with squares of grass that area each 1 foot on each side. How many squares do you need? If you draw a picture, you can see the answer is 30 equals 6 asterisk 5. Now suppose you have land that's 6 feet long but 0 feet wide. In other words, it's just a 6 foot long line in the dirt. How many squares can you fit in that line? None. The area is 0, so 6 asterisk 0 equals 0.
We continue with Dave Consiglio's answer. It's not so much that someone decided. Rather, it's consistent with mathematical rules. What exactly is multiplication? It's just lots of adding. So if you've got say 2 by 3, that's just 3 2's added together. 2 plus 2 plus 2 equals 6. But then, by those rules, 2 by 0 should be 0 2's added together. Yeah, see, you don't add any 2's to anything. And thus, you get what you started with, which was nothing. We continue with Nandan Choksi's answer.
There are many ways to understand this idea. I'm going to use the number line. Multiplying means doing the same thing over and over again, a certain number of times. So, let's look at a number line, using absolute numbers. Let's say the line has 0 in the middle. To the left there are 10 spots. They go from -1 to -10. To the right there are 10 spots. These go from +1 to +10. Now, imagine this. You move 3 times to the left, from 0 to -1. How many times did you move? 3 times. This is the same as moving from 0 to -3, 1 time. You still make 3 steps, from 0 to -1 to -2 to -3. In an absolute sense, you have taken 3 steps whether you go from 0 to -1 3 times or you go from 0 to -3 1 time. The same is true on the other side of 0. Whether you go from 0 to +1 3 times or you go 1 time from 0 to +3 1 time, you have taken 3 steps. Whichever way you go, 0 to 3 is 3 steps. It makes no difference if the number line is a straight line, a circle, or a sphere. 3 steps is 3 steps. Now, imagine you go from 0 to 0. Whether you do it once, twice, or any number of times, you start at 0 and you end at 0. You have not taken a step at all. You have remained at 0, without moving, the whole time. The same is true of any number. If you go from -3 to -3, without taking a step, you have taken 0 steps. If you go from +3 to +3 without taking a step, you have taken 0 steps. No matter what the number, if you have not taken a step you are standing still. Standing still is 0. To me, the advantage of seeing it this way is that the distance from 0 to any other number or the distance between any two numbers is irrelevant. Here, if you don't move, you are at 0. If you move once, you are at 1, twice you are at 2, and so on. The distance and the direction are both irrelevant. All that matters is how many times you move. The distance from x to x is always 0. The distance from y to y is always 0. It makes absolutely no difference at all what value you attach to x or to y. It makes no difference how many times you measure this distance or how you measure it.
We continue with Alan Bustany's answer.
The same people who decided a plus a equals 1 times a plus 1 times a equals 1 plus 1 times a equals 2 times a. A plus a equals 1 times a plus 1 times a equals 1 plus 1 times a equals 2 times a. It is basically the distributive property of multiplication over addition. The fact that for any a, b, c, we have a plus b times c equals a times c plus b times c. A plus b times c equals a times c plus b times c. This characterizes multiplication in relation to addition. It results in multiplication being repeated addition for elements that are simply a sum of ones, namely integers. It essentially forces multiplying a negative by a negative to be a positive. And, of course, it forces a times 0 to be 0 for any a. There are algebraic structures in which one operator does not distribute over the other operator, but such operators are not usually referred to as multiplication and addition.
The video is over. Thank you for staying until the end. Remember to subscribe if you liked the video. The likes also help a lot for referencing. You know what you have to do. The video is over. You can continue discussing this question in the comments, or find another question that interests you. See you next time.